Uh, this is Dr. Zhang. I want to talk a little bit about Lab 1 and the requirement. So as you see, I divide Lab 1 in terms of submission to two parts. The first part is graphing. In that part, you need to make a graph and then either turn in this piece of paper with the drawing on it or take a picture and turn it. The second part is the statistics part. This part you just turn in uh, following the requirement. Basically, you don't have to turn these pages. I put all these questions in the as multiple either multiple choice questions or fill in blank questions. You can just answer those. Okay. In there. So let me talk a little bit about the graphing part. So first of all, there's two columns of data here, time and position. Notice that you need to put time as horizontal axis, which is this axis, okay? Position as vertical axis, okay, as we require, okay? So the first important thing, you have to choose a good scale for your axis. This scale need to be, first of all, fair or even, meaning that when you go from one to another box, the value increasing should be the same, okay? Try to use a significant part of the graph, okay? Secondly, you need to put these numbers onto the graph as explained in this handout, okay? And then you need to try to fit them with a straight line using a ruler, okay? So you make those dots based on the scale and then use a ruler to draw a straight line. Well, it is possible that not all the points are on the line. In that case, you just try to make as many points as possible on the line. Some points can be off. That's fine. Okay, that's called fitting. Okay. And also remember, you need to answer this question, what would the position of the object be at 0.8 second? So notice that this time goes from 1.0 all the way to here. So 0.8 is not in this range. In that case, just use your plot, try to extrapolate to 0.8 second, see where this um, position could be. Okay, so that's my suggestion for the first part, for the graph. For the second part, statistics, everything should be straightforward. Okay, just follow the definition and example in the handout to calculate this. For the percent difference, just keep in mind you're doing the difference between largest and smallest value. So the largest value is kind of like the first number, and then smallest, if you go back here, the largest value is kind of your value A, and then the smallest value is kind of your value B, okay? First and second, okay? And then you just do the calculations and then put your answer in as filled in questions in that place I put there, like right here. See you submit your statistical question part here, okay? And and then answer a couple questions here. There's a multiple choice that you answer. So when you compare the data set, which is the best or most reliable, well, remember these measurements are for the same value. So if the numbers are really close to each other, that means it's a much more reliable measurement. If they're all kind of spread out, that's not very reliable. Okay, that's the key. Okay, that's my two part of comments or introduction for the homework for the lab one. Thank you.